Welcome back to my channel. We have an amazing geometry question to solve. I wanted to draw this, but I said no, if I draw it you may not really understand the drawing, so let me continue. This is a square. Please, this is not drawn to scale. This is a square and this is a quarter of a circle, and we have another quarter of a circle coming from here. The center of this one is here and the center of the next one will be here. So let's draw another quarter circle. Please, this is going to be a freehand sketch, okay? So I'll try. Okay, so this is another quarter circle. All right. Now the question says that the length of this square is 2 units. Okay. All right. Now we are asked to find the area of the shaded portion. Now this is the shaded portion. This side and the other side. So this is the shaded portion and this is the other shaded portion. These two are symmetrical. They are equal because the quarter circles are equal as well. All right. Okay. So we are asked to find the area of this shaded portion. Now do not use calculus. Can you do this using the knowledge of geometry? Okay. Now first of all, let us join from here to this center. Okay. So let's join from there to this place. All right. Now if you look at this, okay, you can see that it is the radius of this particular quarter circle. All right. So this is the quarter circle, and from here the center of the quarter circle to its circumference, this is the radius. All right. And you can see that the radius, which is also from here to here of this particular circle, is 2. Therefore the radius is constant, right? So that means this is also 2. Similarly, let's join from here to here as well. Okay. Now if you do that, you are going to get the same thing. From here to here is the radius of this particular circle. All right. This particular circle, this is the center from there to there, so the radius is also 2. Now you notice that we have formed a particular type of triangle called the equilateral triangle. So if we name this place A, B, C, and D, and let's call this O. All right. So you can see that triangle AOB is an equilateral triangle. AOB is equilateral. It is equilateral triangle. Now one thing about equilateral triangle is that all the angles are equal. So this is 60 degrees. The same thing, this is 60 degrees. This is 60 degrees as well. All right. Now at this point, what is this going to help us? Now if you look at this, you see that we have a sector of a circle. AOB is a sector. Okay. So area of sector AOB, okay, area of sector AOB is equal to, remember that area is theta over 360 multiplied by pi r squared. Okay. Now our theta is the angle subtended by the sector, and the angle subtended by the sector is what? 60 degrees. All right, 60 degrees. All right, so we have area of sector AOB is equal to 60 over 360 multiplied by pi multiplied by, now the radius is 2, right? 2 squared. So we have area of sector AOB is equal to 60 divided off 1. If we divide 360, we have 6 multiplied by pi multiplied by 4. So we have area of sector AOB is equal to 2. We divide this to give us 3. Divide this, sorry, 2 we divide this to give us 2. Divide this to give us 3. So we now have 2 times pi, which is 2 pi over 3. Now we are going to keep this, all right? We are going to keep this. Now let's look at the equilateral triangle. The equilateral triangle AOB, okay? Now let's try to find its area. So we have a triangle. Now triangle AOB is an equilateral triangle. Therefore, its area, okay, its area is equal to, this is equilateral. Therefore, area of triangle AOB will be equal to, this is triangle AOB, okay? So area of an equilateral triangle is equal to square root of 3 divided by 4a squared. You can still go ahead and find the height, and then use half base times height. But if you do that, you are still going to get the same thing, all right? So whereby A is what? The side. So area of AOB will be equal to square root of 3 divided by 4 multiplied by 2 squared. So we have the area of triangle AOB will be equal to square root of 3 divided by 4 multiplied by 4. Have you subscribed to our channel? If not, please do that, alright? Turn on your notification bell so that you don't miss our videos, and tune in at your convenience. You see something to watch, give us a thumbs up if you love what we are doing. Thank you very much. So at this point, this will remove this, and we have that the area of triangle AOB is equal to 4. Now, at this point, I want us to look at this place. Notice that we have a portion here in between the sector, right, and the triangle. Now let's call this x1. All right, so that means to get the value of this x1, I will subtract the area of this particular triangle from the area of this sector. Okay, so we have the x1, area of x1 is equal to area of sector AOB minus area of triangle AOB. So x1 will be equal to, now area of sector AOB is 2 pi over 3. 2 pi over 3 minus area of triangle AOB is 4 minus 4. Sorry, I made mistake here. When this cancels this, our area becomes root 3. Okay, so area is going to be root 3, not 4. Thank God I found out on time. So this is what? Square root of 3 minus root 3. All right, now let's go back to the diagram. If you look at this diagram, you notice that from here to here is 60, and the whole of this is 90 degrees, right? Being that this is a square. So that means that the remaining portion, which is from here to here, is 30 degrees. So as a result, this is what? A sector again. So we have sector OBC, the whole of this. Now let's try to find its area. So area of sector OBC, area of sector OBC is equal to theta over 360 multiplied by pi r squared. All right, now our theta, so area of sector OBC will be equal to, the theta is 30 degrees, right? So we have 30 degrees here, 30 degrees. So it's going to be 30 divided by 360 multiplied by pi, and our r is what? 2 squared. So we have that this is equal to 30 will divide itself. 1 divide this to give us 12. So we have 1 over 12. Okay. Then multiplied by pi multiplied by 4. So this will give us, this will divide itself. 1 divide this to give 3. So we have pi over 3. That is the area of sector OBC. The whole of this. The whole of this. Okay. Now remember that I want to get area of this side, right? Now let's call this shaded portion x2. Okay. And call the whole of this sector x3. Now if I want to get x2, I would have to subtract x1 from x3, right? Okay. So area of the shaded portion, area of the shaded portion, area of the shaded part will be equal to, so this shaded part now will be equal to the whole of this, which is area of sector OBC, right? So it will be area of sector OBC minus area of what? Our x1. So just minus x1. Yeah. Now we continue. So we are going to have that this will be equal to, now area of sector OBC is pi over 3 minus, now x1, let's go to x1. Our x1 is 2 pi over 3 minus root 3. So we have minus 2 pi over 3 minus root 3. Okay. So if we continue, hope you have subscribed to the channel. Hope you have subscribed to the channel. Okay. Now, this is what we have. I will draw the area of the shaded portion. Will be equal to pi over 3 minus, this is what we have here, 2 pi over 3 minus root 3. So this is equal to pi over 3 minus times this will give us minus 2 pi over 3. Minus times minus is plus, and we have root 3. So this is equal to, they share the same base, right? The same denominator. So we can say this is pi minus 2 pi plus root 3. So this is equal to pi minus 2 pi is minus pi over 3 plus root 3. Okay. Now this can be written as root 3 minus pi over 3. But we have two shaded portions, not just one, right? And they are symmetrical, they are equal. Therefore, area of the shaded portion, the total area will now be equal to 2 multiplied by root 3 minus pi over 3. And that is our answer. Thank you for watching. See you in my next video. Bye.